Okay, in this video we're going to take a look at the conservation momentum worksheet in collisions. Now remember, law of conservation momentum, so loco P, states that the total initial momentum, so sigma Pi, has to equal the final momentum, so sigma Pf. So the way that I try and do this is I try and build this. This is always my initial equation. But I always start with total momentum initial, total momentum final. And then I build the equation that I'm going to use from this. And the way that I do that is I say, all right, well, looking for my initial momentum. So I look, all right, before the collision, how many objects do I have? I know I have two objects here, so I'm going to go P1 initial, and then plus P2 initial. And because there's two objects, I put in P1, P2, and from there, then I go, oh, it's M1, V1 initial, plus M2 V2 initial. So what I'm trying to do is I'm trying to show you like this equation down here is the same as this equation here and then this equation here. All I'm doing is kind of expanding it out. Now, sometimes you're going to get in the habit of just like, oh, well, I see there's two objects, so I'm just going to go M1 V1 plus M2 V2, and you're going to get it done that way. But if you start with this highlighted equation first, you start with this one first, you can never go astray, because what could happen is I could give you one with three objects, and then if you're only used to using two, you're like, oh, I'm going to freak out. But if you start with, okay, start with initial momentum equals total initial or total final momentum, and then go, all right, how many objects before, how many objects after, you'll definitely get it right then. Okay, so let's keep going on this. So P1 initial plus P2 of initial, and then that's going to be equal, I'll go back to the black here, that's going to be equal to, after the collision, I still have two objects. So it would be P1 final plus P2 final. And that's going to equal M1 V1 final plus M2 V2 final. Okay, so there I can now use my stuff. So that was my equation I'm going to use. And I kind of got ahead of myself. I should have been guessing during all this. I should have been putting in here, oh, M1 is going to be 1 kilogram, and V1 initial is going to be 2 meters per second, and then I've got M2 is equal to 2 kilograms, and V2 initial, that's going to equal negative 2 meters per second. Now, it's got to be negative because direction matters. Velocity, momentum, they are vector quantities, and as such, direction matters. So I've got to take into account. So if this one's going right and this one's going left, something has to be negative. And I automatically default to right being positive, left being negative as soon as I see that they're going in opposite directions. So I can put this down. If I look after the collision, M1, M2 stay the exact same, but now I have a V1 final. So I'll put that in orange. The V1 final is now a negative 1 meter per second. So once I know this, there's all my givens, and I'm looking for V2 final. That's my unknown. So I already grabbed my equation. So I'm just going to plug things in. So I've got to start with the 1 kilogram times the 2 meters per second plus 2 kilograms times the negative 2 meters per second. And that's going to equal 1 kilogram, because M1 didn't change, times the negative 1 meter per second plus the 2 kilograms times the V2 final. That's what I'm looking for. So going down through, and I'm going to do this one all the way out. So 2 times 1, I'm going to drop units from right here. So I've got 2 plus 2 times a negative 2 gives a negative 4. And that's going to equal a negative 1 plus 2 times VF. So 2 times a negative 4, 2 plus a negative 4 is going to give me negative 2. Is equal to a negative 1 plus 2 times VF. So now I add over on the 1, so I get when I add this 1 over, I'm going to end up with negative 1 is equal to 2 times VF. And so now my VF is going to equal a negative 1/2, and now I put it in my unit again, meter per second. So my answer here is that it's going to be going this direction at a negative 1/2 of a meter per second, or negative 0.5 meters per second, if you'd rather do that one. Okay, so we come down here, and number 2, and I'm going to try and, I actually need to grab this stuff and move it up a little bit because I seem to have run out of room here. I'm going to slide that up. There we go. All right, and then we'll come back to this. So after the collision, these two cars stick together. Find the velocity of the two cars after. I'm going to drop the 2. Hang on, let me move that. There we go. Okay, so once again, let's go through our guess. So we've got M1 is equal to 1 kilogram. V1 initial is equal to 2 meters per second. And now M2 is equal to 2 kilograms. And V2 initial is going to be 0. And then we're looking, since they hit and stick together, okay, I'm looking for V final. That's my question mark. So V1 final and V2 final, if you will. So I'm going to go back and I'm going to use my loco P rule. So sigma Pi is equal to sigma Pf. And I know I have two objects, P1 plus P2 before the collision, but I only have one object after. So that's just P final because they hit and stick together. So see how the equation has changed based on what the outcome was. So I can write this down that M1 V1 initial plus M2 V2 initial is equal to, now because they hit and stick together, it's M1 plus M2 times V final. So now I plug in the stuff. Okay, I've got M1 is 1 kilogram times V1 initial, which is 2 meters per second, plus 2 kilograms times 0 meters per second is got to be equal to 1 plus 2 gives us 3 kilograms, and we're looking for VF. So when I do this, I get 2, and I'm going to drop units, plus 0 is equal to 3 VF. And so when I solve this, my VF is going to equal 2/3 of a meter per second. Okay? So my answer to this is going to be going forward. My VF is equal to 2/3 or 0.667 meters per second. And I could leave it as 2/3. That's actually more accurate, but if you want to spit in the decimal point there, or the decimal number, the approximate number, that's perfectly fine. Okay, so number 3 says after collision, the two cars stick together, find the initial velocity of the car on the right-hand side. So again, let's go down through and let's guess. So here's our maroon. We've got M1 is equal to 1 kilogram, and its initial velocity is equal to 3 meters per second. We have M2, oops, sorry, I wrote that wrong. M2 is equal to 1 kilogram, and its velocity, V2 initial, we don't know. That's what we're looking for, so that's our unknown. And then we have after the collision, so V final, they're moving at 2 meters per second. So again, I'm going back to my law of conservation of momentum. So sigma Pi equals sigma Pf. So P1 plus P2, because I know there's two objects before the collision, is equal to P final, because there's only one object after the collision. So M1 V1 initial plus M2 V2 initial is equal to M1 plus M2 times V final. Now, I understand this is massive overkill, and this is an awful lot of writing, and you're going to get bored of doing it really, really fast. But I can tell you that if you don't take the shortcut, if you don't jump right to the end, you're not going to get it wrong. So if they throw something screwy at you, you're going to know how to do it. So I encourage you, do it all the way out. It's kind of a pain in the butt, but it's worth it. Okay, so we look down here. We've got M1 is 1 kilogram. We know V1 initial is 3 meters per second. I forgot to put that in there. There we go, 3 meters per second. M2 is 1 kilogram. And we don't know what V2 initial is. That's what we're looking for. Is equal to, now it's M1 plus M2 since there's one object. So that's 2 kilograms, and we know that it's traveling at 2 meters per second. So now I'm going to plug this in. So I've got 3, or 1 times 3 is 4. Sorry, 1 times 3 is 3, my fault. And then plus 1 times V2 initial, so I can just put that as V2 initial, really, since I'm dropping units. And this is going to be 2 times 2, which is going to be 4. So when I bring this through, 3, so V2 initial is going to end up being 1 meter per second. Now, in reality, I probably shouldn't have dropped units there, because technically this is 3 kilogram meters per second, and this is 4 kilogram meters per second, and this is 1 kilogram times V2 initial. But I think you kind of get the idea, and that's why I cheated at that point in time. So this initial velocity, V2 initial, would have to be 1 meter per second. All right, we've got number 4. Two cars are at rest with a spring in between them. The spring is released by the mass of the car on the right-hand side. So let's go through what we know. We know that M1, I'm going to call this 1 and call this 2. So 1 and 2 again. So M1 is 2 kilograms. And we don't know M2. M2 is question mark. But we do know that the initial velocity of them is 0 meters per second. After the collision, once again, we know M1, so I'm not going to rewrite that. But we do know that V1 final is a -2 meters per second. Again, it's negative because it's going left. And V2 final is a positive 0.5 meters per second. So I go through here, and I start off with my loco P again. Sigma Pi is equal to sigma Pf. So I have two objects before. P1 plus P2 is equal to P1 final plus P2 final. And I forgot my initials over here. Let's put that in. So we go M1 V1 initial plus M2 V2 initial is equal to M1 V1 final plus M2 V2 final. Now, I could take a shortcut here, and that since I know that both of these have an initial velocity of 0, that means this is going to be 0, and this is going to be 0. So 2 times 0 and something times 0 is still going to be 0. So I can just make all of this 0 if I want. Make that equals, so M1 is going to equal 2 kilograms times the -2 meters per second. Don't forget the negative, that's important. Plus M2 times 0.5 meters per second. So when I solve this, I get -4, and I'm going to drop units right here, plus 1/2 or 0.5 m. 0.5 times M2. So when I add over the 4, I get 4 equals a 0.5 M2. So when I divide through by the half, I find that M2 is going to equal 8 kilograms. So this mass is going to have to be 8 kilograms. M2 is equal to 8 kilograms. All right, and then the last one, number 4. A cart is moving at constant speed, but a frog falls straight down the cart and sticks to it. The frog had no horizontal velocity before landing on the cart. So here we have the beforehand. So I'm going to write down everything I know. So we'll go to orange on this one. So we know that cart 1 M1 is equal to 1 kilogram. And velocity initial of 1 is going to be 3 meters per second. And our poor frog, we're not sure. No, we don't know how much mass the frog has. So M2 is question mark. I'm not sure. But I do know that V2 is got to be 0. Because even though he's falling straight down, he has velocity vertically. He has no horizontal velocity. And since momentum is a vector quantity, we're only going to look at the horizontal right now. We could later on look at the vertical if we wanted to, but it's not crucial for at this point. Not crucial for our purposes in Regents. We won't ever get one that nasty. We might in AP, but not in Regents. So after the frog falls out, oh, there's the mass of the frog. I didn't read that far down. So here we go. Mass of the frog is 0.5 kilograms. All right, and then we move forward after the collision. We know the mass, so we know, we're looking for the velocity total. So we're looking for V final since they hit and stick together. So going back to my loco P, so sigma Pi equals sigma Pf. So P1 plus P2 is equal to P final. So M1 V1 initial plus M2 V2 initial is going to equal M1 plus M2 because they become one object, times V final. So we put this in, we have 1 kilogram times the 3 meters per second plus 0.5 kilograms times 0 meters per second. So I could have just put in the 0 and been done with it. And so now M1 plus M2 is going to be 1.5 kilograms, and we're looking for VF. So this is 3 plus 0 equals 1.5 times VF. And so my V final should be a whopping 2 meters per second. Yep. All right, then part B, the frog decides to jump straight back up to a branch with the speed of the cart after the frog jumps up. Okay, so again, we can talk about this initially. So hang on. If we highlight this, this is what it was. Okay, this is what it was before the frog jumps back up because it was there. So we do know the V final. So I can do my sigma P initial equals sigma P final again, except now my initial is when the frog and the cart are still together. So that is going to be, I can just put this in, 1.5 kilograms. Hang on, let's not cheat. Let me do it right. We have a mass total. So M1 plus M2 times V final, or times V initial. And then we're going to have M1 plus, or M1 V1 final plus M2 V2 final. So here we have M1 and M2. We know that's going to be 1.5 kilograms. our V1 is going to be 2 meters per second. And that's going to equal M1, which is 1 kilogram, times its velocity, 3. Or, well, hang on. Actually, that's what we're looking for, V1 final. And then M2, which is 0.5, times its velocity horizontally, which is 0. He jumps straight up, so not forward, not back. So we got 0, boom, boom, boom. So V1 final is going to go back to that 3 meters per second. So as long as the frog isn't jumping forward or back, he's just jumping horizontal, he's just jumping vertically, that's not going to increase or decrease the momentum of the system. It will change the mass of the system, thus